Developer satisfaction is not measured by the lines of code submitted, but how well those lines flow together. Welcome and thank you for coming. My name is Josh Allen. I'm a lead engineer here at GitLab. I'm going to talk this evening about React Native, what it is, how it works, but more importantly, some of my experiences with it. Just so I have an idea as to who my audience is, how many people here have used React Native on a real project? How many of you are considering using it or have considered using it in the past? So if you have been thinking about using React Native on your own projects, then hopefully this information will help you guide your decision making. If you haven't noticed, there is a spoiler in the title. I swear my final record. There will be times for questions at the end of the presentation. If you strongly object to what I'm saying, there will also be time for objections at the end of the presentation. So I would like to give a thank you and props to the engineers at Facebook and contributors to React Native. They do try very hard and they have good intentions. It can seem like an easy route to talk negatively about a subject. However, I've seen such a continuous stream of blog and articles about why React Native is the future of mobile app development that I felt like it deserved and needed a serious reality check. So that's why I'm here today. So, who are you? Who is this you that React Native is not for? Or I'm going to present arguments such that I think that's the case. Well, you're someone who wants to develop high-quality applications. So this can be measured in terms of how they look, how they perform, as well as maintainability of the underlying code. We're also concerned with cost, because no developer works in a vacuum, separated from business concerns. If you did, you would be an artist rather than a professional. You also know that users' expectations are very high on mobile. If they wanted a web page, they would open a browser and use it. Instead, they went to all the trouble of downloading a beautiful app, and now they wanted to dance. They wanted to dance under their little finger, dance, app, dance. So what is React Native? I know many of you, or some of you, are very familiar with it. Some of you have heard it briefly before, so I'm just going to go through it for those that haven't seen it before. So it uses the React Web Library. This is a very popular web library for web applications. Note that it actually does use the library. Like, you actually include that library as a dependency in your app. It also is used for cross-platform development. So that means that you write the code once, and then it, not necessarily write it once, but you do have you can have a common code base, or at least a common platform for which to deploy on Windows and on Android. And this is the native components. This is what makes React Native stand out from other cross-platform solutions such as Cordova. Because under the hood, it actually renders to a native component as opposed to being rendered in a web view. So in React Native, there are no web views. It is actually a conversion of JavaScript to native components, which makes it seem very attractive. So yeah, this is the magic. So just to kind of get it out of the way, this is basically how React Native looks. If anyone, most developers have had some coding experience in JavaScript, so much of it is very familiar. Those of you that haven't used JavaScript in a few years, welcome. They actually have classes now, so it's pretty cool. They're not real classes, but I don't want to get too much into that. There is something unusual about this, though. If you notice, so you have the import statements, that's also ES5, maybe ES6. And so everything is extending components, so this is a common idiom in React. So this looks very much like a React code. The difference, which differentiates from a plain JavaScript file is the seemingly XML or HTML in the middle of the JavaScript. Notice there's no quotes around it. It's called JavaScript extension, so that's a valid XML file. And here you are in the render method, which you can guess what that does. You're basically defining a simple variable picture, which I'll show you, which leave you anticipation of what it is. And you have the text view. This gets rendered to a text view, native text view in Android and in iOS. It's actually not necessarily the text view from the SDK. It's a little bit more complicated than that. They have their own UI widgets. And then image view, which translates to something similar to image view. And that's what it looks like. So this is actually a complete application in React Native. There's no other files necessary. There's just some, obviously, getting your dependency management up and running. There's actually, if you've done any of the tutorials, there's actually a in-browser interpreter for React Native, which is like pretty amazing. You actually go type your code in the browser, and then it brings up this image here, and we'll show you what it would look like in React Native, which is great. It's kind of like when you're in the W3 schools, and you want to edit the HTML on one side and see how it renders on the other side. It's similar to that. It's done with the power of React. All right, so why are people choosing cross-platform? Because they want to save time. Building 2 separate applications is very expensive. It can involve 2 separate teams. Often it does. You often have your Android team, your iOS team used to have other teams. But know that this is not a stated goal of React Native, as we'll get into later. However, to be realistic, this seems to be why people are drawn to it. Another reason is that they want to learn it instead of a native platform. Maybe they're web developers. The learning curve seems easier if they already know React and web development to get into mobile development. It seems like an easy transition to learn React Native. So that's another reason. Yeah, so learn once, write anywhere, which is the tagline of React Native. It seems like a valid goal. However, this seems more like an organizational goal rather than a development goal. You give any developer the chance to, on-the-job training, to learn a new platform. It's going to help their career, kind of exciting. I think most developers would jump at the chance. But certainly, organizations do look at this as one reason for choosing it. So the real reason why people don't choose a cross-platform solution such as Cordova or PhoneGap, they can get away with it because they don't like the compromises that it forces them to do. So they don't want to compromise on performance. They don't want to compromise on UI design. They don't want to compromise on the look and feel. Like I said, the users want the application to dance, so they don't want to. The developers don't want to have from the onset coming from a disadvantage. In some ways, this is the dream, the Holy Grail of mobile software development. Write once, run anywhere. Does that sound familiar to anyone? So this is the actual official focus of React Native. So although developer efficiency is ambiguous, it is commonly interpreted as meaning that you do not have to learn more than one platform. Instead, you learn one platform, React Native, and can deploy on both iOS and Android. Think about this official statement, though. Is this why you want to use it? Often you have other reasons for using React Native than the official goals. And when you talk to people about why they're choosing it, it's because they want to have one code base, they want to do code sharing, they want to have save development time and money. So this is usually the reasons people get for choosing React Native, not the fact that we only have mobile developers. We don't have web developers, we don't have any mobile developers, so let's go with something that they can learn. Although there are some companies that have said that. There's the reason, like SoundCloud is one reason, they said they had no mobile developers. So they had no, they had no mobile developers, they had a bunch of web developers. They didn't have that had access to web developers, so they chose to use React Native. So there's a lot of hype and a lot of noise, so we're going to try to cut through it. This is I'm going to show you a quote from an article. This is basically the first, this is on my first page. This is on the first page of a Google search that I recently did. Essentially, there's a lot of noise because a lot of technical content is being submitted without being peer reviewed. Yeah, so these folks were able to solve their requirements problem by copy-pasting. So let's cut through the noise, shall we? So this is an overview diagram of what React Native is going on under the hood, just so you know there's no magic involved. So JavaScript Core, this is the same library that is used by Safari. It's written in C++. It's been around for a long time. It's a large code base. So this is actually deployed in your application. So you actually have the Android native, which is running in the JVM, and you have your JavaScript Core, which is running in C++, so it's not on the JVM. So essentially you have two virtual machines in the app, and the way they communicate is over an asynchronous bridge, which is called the JS bridge, and they allow simple message passing. So they can send strings and primitive types across the bridge. So that's essentially how it's communicated, and then you basically send the JS core your JavaScript files, and that includes all the React and all the other Node libraries that you want to add. Now this might have some consequences that you aren't aware of at first. For example, anytime you're networking in the JavaScript in React, which is almost all their applications doing that these days, it actually gets sent that networking is actually happening on the native side. So although it looks like it's happening in JavaScript, it's being sent through this asynchronous bridge request to be done on the native side. So far, so good. What happens if you put your app in the background? Well, all those messages get queued up. So every time your app goes to sleep, the asynchronous bridge sleeps with it. But your native code can still be running in the background, as we know. So you have to be careful that, for example, say you have you're listening to a web server and it's streaming you data. When you turn the app back on, you're going to get flooded with messages on the JavaScript library. So you need a way to deal with that. We had a similar problem with telemetry data. So basically the telemetry data, which is like, telemetry data is like where the phone is in space and how it's positioned. So we were basically sending data far too fast than that could be processed by the bridge, so we had to deal with that to make sure that messages weren't being essentially queued up in volume. Okay, so you saw don't be afraid. You saw the React JavaScript side. This is how it looks in your code. Just to give you an idea, like there's no magic involved. All it's doing is, see this got this React instance manager. This is essentially an instance of that JavaScript core virtual machine that we talked about. You say, hey, we're giving it the first entry point to application, that's index.android. It also has a special way of doing assets, so that's done through the assets. That's done through the assets file, as well as that JavaScript bridge that I talked about, like where you can call your JavaScript code into your Java code and vice versa. That's done in the add package, so you define what those interfaces are, those custom interfaces are. So all in all, looks pretty great. Now, you might wonder, well, what can I do like what kind of interactions can I do between JavaScript and native. So this is a pretty advanced example. This is with someone is taking, we want to find out what the average color is on a view. We don't have that functionality in JavaScript. There's no library to get us to do that, but hey, we have that functionality in Android. How are we going to do that? Well, this is the core piece of the code, how it happens. You basically see where it says view equals navigation view hierarchy manager dot result view, given a tag. So that tag is sent from the JavaScript layer using the JS bridge to native layer, and then it's actually getting the native view that React code rendered into. And then we're checking to see if it's sized, and then we're essentially creating a bitmap with it. You can do this. This is a common idiom in Java to just basically draw a view to a bitmap, and then you can do manipulations with it. So we're doing the same thing, but that's essentially getting the actual view that was rendered with our JavaScript code and getting access to it in native, and then in this case getting the average color. But you could also take a snapshot of it and do other things with it. All right, so there's so much information. The big test, how are we going to essentially evaluate, is this something we should continue with or not? Is this gonna work for us? Well, the ultimate test, other than usual finding all the, doing little investigations and reading tutorials, and like I said, there's a lot of noise. Just build 3 identical apps and test them out, see how they do. So you build one app in Android, one app in iOS, one app in React Native, and you just test them. You see how do they perform. What's the development cost? Is it actually proving to the hype? So we weren't sure what the results were going to be. We were pretty sure React Native was going to come out ahead. So we talked about 3 platforms and then 1 set of requirements. So we had some pretty intensive mock-ups to make sure that we are going to test it adequately, as well as a bunch of performance criteria that are outside of the scope of this talk. So this is one of the things that we did was this animation. You might notice, some things you might not notice is that it's going from a circle to a square. It's getting a little bit bigger. It's moving up a few pixels, and it's blurring the background at the same time. So all those things are happening at the same time, so it's a pretty good test in terms of what you might want to do with a simple animation. You've seen plenty of these in apps that you use. So you can see it's circle, square, so that's one transformation. Then it's moving up, so that's another transformation. You're also doing blurring. Blurring is always a pain in Android. I haven't seen a really good implementation of blurring that handles all the use cases yet. So this is the test. So even in native, this is going to take some effort to do properly. So what do you think happened? Well, does anyone know what a janky frame is? So a janky frame is considered anything. Okay. Control the question. Janky frame is considered if it's less than 60 frames per second, it's considered a janky frame. That's what there's some developer tools that from ADV that you can use that will tell you how you're doing it, how your app is doing in terms of frames per second. Most developers don't really use them because their apps usually work fine, but if you're ever troubleshooting, you can use. Actually, it's a great thing to know how to do it. It's pretty cool, especially look into it. All right, so frames per second. So basically, we want all of our frames to be in the 60 column. So with pure native, boom, worked great. With React Native, it wasn't so great. Basically, 98% janky frames. So I'll have a demo app on a couple of phones where you can see it. Now, just so you know, this is after we finished the project, we went back and looked at the animations to make them even more efficient. So this is like, with some other data I'm going to show you, this is even better than what we were able to get to before. This is like even going back and doing more effort to make sure that we're using all the animation libraries properly, we didn't miss anything, and that we optimized some of the blurring that we didn't have a chance to do before. So we were hoping we would get better. And then something else you might not realize is that React Native does everything in one. It doesn't have to, but most of the time, the way people develop their apps is on React Native is that all their application is one activity. So you have one activity in all these multiple views. So the more views you have, the more pages you have. That's sort of just getting added to the backstack. So in Android, of course, if you have too much, if you're running out of memory, the operating system is going to kill one of your activities, but it's not going to kill your whole application. So it's not impossible to do on React Native to do that. It's just not how people do it. So that's why we had to do another. I wanted to do another test with how does it perform with this high amounts of RAM? Because you open up a bunch of pages, you're going to be ending up using more RAM. All right, so everyone here loves view recycling, right? You guys love view recycling. Okay. So React Native, it's not really possible to do view recycling, so you can't really have like super long lists. Or if you do, they're not going to perform very well. They're going to run out of RAM. So one of the requirements we had was to support large lists. So this is one way to do it. So we have this infinite list view. This is the kind of stuff that you start getting into with React Native when you hit a wall and you're like, we need this to work well. And so we ended up diving into the source code for how they do their list views. You try to figure, and first of all, you figure out, holy crap, they're not doing view recycling. And then you realize, wow, they can't do view recycling. It's like impossible with their architecture. Like it's just, if you think about like how they have the creation of the views, for example. Let's just go through this code so you guys aren't completely lost. So we have this infinite list view. It's just inheriting from React components, just a regular component. We're basically have so say there's 100 items in the list, you're showing 10, you just create a fake spacer view for the top 90. So that's what that spacer height is. It's just saying how much of a spacer elements are you going to have. And this is actually what they do on actual web pages. So this is we didn't invent this. This is a common solution to dealing with long lists on web pages in React. So you have like a long spacer view, and then you just only render the 10 that are visible. And then what happens is when you scroll back, then it takes some time, so you have to re-render those views. So there are some performance hits. Yeah, so the issue is why they can't do view recycling is there's no mapping in code between the native component that's being rendered, which is like so in view recycling you need to have this is a particular type of view, and this is the data that goes along with it. Well, React Native, I could decide to put anything in that loop on this iteration. So in that case, it would be a different view, and then there wouldn't be the data to go along with it. So that's one of the issues they have with implementing view recycling. So development time. So basically we got to about 80% of the project and we're like, oh wow, freaking React Native is killing it. Like look at that. They are almost half the time of an Android and iOS app. Like, this is amazing. We basically cut our development costs in half. Like, think about what that would mean for how much more you could do with the application, right? How much, what an advantage of that it would be.
Which color is which?
Oh yeah, sorry. This is React Native. used to Android and iOS. They're relatively similar. So a lot of people would just make a decision at this point rather than completing it. However, we didn't stop there. We had these comprehensive mockups to match, and this is where the tide turned heavily against React Native. You can see that the development effort for the last mile, the effort that turns map from ugly to beautiful, from glitchy to performant, from demo to production, that the development effort for the last mile was 4 times that of native. So in total, the time and cost of the effort ends up to be 50% more than just doing a complete from scratch Android and iOS. So this is also like I say, we went back and tried and did even more work, so it actually doesn't represent all the costs. That we also include account of the fact that, hey, some of this work is not going to be required as the application scales. You do it once, you don't do it all over again. So we did add some accounting for that. So our findings were very surprising. So we discovered that React Native is very fast initially, to the point where the features were on par with Android and iOS with the same amount of time. It's just that you'd be like, oh, well, it's not quite done. We kind of need to revisit that. Like, it'll be fine. We just need some extra time to get that in. But that turns out the extra time to get that in just threw everything out of the water. So what's done in the last mile? So we're doing the UI polish, making sure it matches comprehensive. We're doing performance tuning. Essentially, the native applications were like a baseline, or this is how fast as it should be, or as it could be. So let's see if we can get React Native there. And then also memory usage, for example, the long histories. So, and as well as tech debt. So this is productionalization of an app. Usually you don't want to leave this to the end. Sometimes if you just wait to productionalize an application until the very end, you might decide to throw the whole thing out. So, however, we never really got to. There's a lot of stuff that will happen at the very end of a project to get it out the door, and we weren't able to do those kinds of build tuning stuff that you would normally do in a production quality app at this matter of time. So, on top of all that, what are you left with when you're done? So what does the maintenance and ecosystem look like for React Native? So code sharing. So we did, depending on which project we're talking about, we could achieve 80%, 40% code sharing. So which is awesome. Having that code sharing is a great thing. If anyone's used React Native in a production app, our experience of third-party libraries is that they are shallow, naively implemented, abandoned at a high rate. 75% of projects are abandoned. 2/3 don't work when you first install them. So, and you start getting a little bit scared every time you're like, oh, should we even bother to use this third-party library? But what is good is you can look at them for ideas like, well, how do they do that? So even if you don't use the code, sometimes they can be useful to well, how do they do blurring? How do they do that animation to kind of give you ideas as to what they're doing? And then sometimes even doing that investigation, they'll say, okay, so it's not going to work because we know the limitation of doing it that way. But in general, the state of the third-party libraries, unless they're made by major players, but most of the stuff on GitHub by individual contributors or most of the stuff is just a few contributors, is very low quality. For one, they're usually not experts in the domain or experts in the native domains. They're just React developers who try to use who need to expose some kind of native functionality. And JavaScript. I really like JavaScript. However, it's is missing a lot of things that they keep adding hacks to try to make work. And flow is one of them. There's no type safety in JavaScript, as we all know. We love type safety because it helps us make changes with confidence. Flow is like an add-on to add type safety to JavaScript. We found that it was good for documentation, but in terms of like actually enforcing types, we found that it was a failure for a host of reasons. One, it was a separate build step. A lot of the libraries were written in flows or didn't have flow support, so it would just be like any object is a common example. So yeah, too bad. So what kind of, okay, so there's that. Now it's like, who can actually do this work? Because I'm telling you, it was hard. Like, I've done lots of development, and this was honestly some really challenging work. So you're gonna need to know at least two of these things. iOS and Objective-C. You're gonna want to know Android and Java. You're gonna want to know Node and JavaScript, and JSX and React. So you're gonna actually want to know at least two of them, and then you're gonna have someone in the company to know fill in the missing gaps. So if you work with a large company, and you can get help from people that do know these things, and that's really going to help you out, because otherwise you're going to end up wasting your time cycling through. It might be a simple problem, but you might not realize it for a while. So it's good to have that input. Also, you might end up doing something on a particular platform the wrong way. You might start trying to code React like a Android application or vice versa. So yeah, so it is challenging. Yeah. And you could survive without importing native projects, but you cannot avoid writing native code, forking a dead library on any real project. But we used to say it's not for the faint of heart. You got to be willing to dive into a broken open source library and fix it yourself. If you're not that kind of developer, and the people you're working with might not be those types of developers, then it might not be for you. So in summary, so goal alignment. So think about what the hype is versus the stated goals. Do those align? Are you aligned with what the official goal is of the library? Because it never said that it was to develop faster on native. We went through a deep dive of the architecture, so we saw some of the fundamental architecture and how that means that you may be playing with a disadvantage compared to native. And then we saw some metrics, so we saw some animation and development time metrics. Obviously, your mileage may vary, but this is the experience that I had. And I haven't seen anyone else publish this kind of information before, so it just seems like a lot of conjecture. I see people go down one way, and they say, yeah, it's great. But I haven't seen the side-by-side comparisons of like, yeah, we did this whole project, and we did this in this way, we did the whole project in this way, this is the comparison. So this is the metrics I have. And then the ecosystem. So one thing I realized is that web developers are in a world of hurt. They have, it's called like web JavaScript insanity. Like there's so many frameworks and hacks on the stuff that they have to do that they just think it's normal. So a software developer goes in who's like used to like awesome builds that just work, that aren't flaky. They don't have to have like 5 different moving components and debug for half an hour as to what the heck's going on this morning. Or like, wow, did that really deploy? I don't know. Let's delete all the caches. Like just on and on and on. Every piece, everything that's got on, and they're like, oh yeah, that's just the way things are. Oh, you don't have type safety? Flow. Oh, that's not good enough. TypeScript. No, it's not. Like, so So yeah, so what web developers can both think as like, that's normal and acceptable. Mobile developers come in and they're like, what the goodness is going on? How do you do this? So it comes down to developer satisfaction. How satisfied are you with the work that you did? Your work day? Did you solve the right kinds of problems? Are those the kinds of problems that you want to be solving? So, who would, actually, I think I'm running out of time. I'm going to skip this slide. Okay, so I just wanted to talk and say that, yeah, again, building on what I said, was talking about before, that data development is solid. We've got Kotlin now. We have annotation processing that's been building, slow build since Java 1.5. That's like, how long ago is that? 13 years ago. Looked that up recently. 13 years ago, 1.5 came out. So now we have all kinds of tools that do annotation processing, like Dagger, and the amazing SQL delight that we just saw. We have data binding that makes architectural components, MVVM, a breeze, architectural components that we talked about last month, as well as ReactiveX and a whole bunch of amazing tools that build clean, satisfying code. So my message to you is stay the course. The future is bright.
Could you go back one screen just so
Yes.
we can see your thanks.
So stay the course. The future is bright. And thank you. I just want to also say thank you to the hosts and Android Toronto Meetup, Dan and Eric, for letting me speak. Thank you for listening.
So it seems like in your example you're doing some heavy image manipulation and so on, and that's why like reacted badly. But like if you were doing just like simple application, like you're just showing some text and so on, like, would you recommend React in that case? Like you're doing something not fancy, but you just want to just kind of get something out there for a very simple use case. Like essentially, I guess like that slide that you skipped, like who's React for?
Yeah, I guess like the question is, for very simple use cases, is the app worth building? Are you doing something? Are you doing a toy for yourself?
Yeah,
Is
like,
it?
yeah.
If you're doing a toy for yourself, who cares? Go for it. Like, but like, are you building something that you're going to be? Is it business? Like, you're going to be? It's not going to be on the App Store, and you're going to have like, you want to make a business out of that. You got some kind of business plan, and it's got to dance. If you want to build that, and isn't that why we build native apps? If you want to build simple text view, use a web page. I don't know. Is someone going to be satisfied to download an app that does that?
Well, I guess I can depend on. Well, like,
I'm a bit riled up.
Yeah. Oh, no. Like I guess I'm just like asking like in general, you know, like I'm not asking for like a very specific use case. Like, I don't have something like in mind. But I'm just kind of wondering like at what point like you say like, you know what, like it's worth going with React because you get two things out of it. It might not be perfect. But.
I don't know of a use case. Just because like there's so much pain. There's so much and then at the end, you have something that is almost as good as what it could have been.
So how much of your team was web developers versus like Android and iOS people trying to work on this? Because like, as you mentioned, the JavaScript ecosystem is a dumpster fire of history. So could it not ostensibly be worthwhile if you teach them mobile paradigms after they've done all your boilerplate code, and then work from there, and then all the pain of the JavaScript ecosystem that you hate so much goes away if you get somebody else to do it.
So we had
You're all okay with it.
Yeah. So those requirements, we had experts. All those experts were on the team. So we had an expert. We had an expert web guy. We had an expert Android. We had an expert iOS. What we didn't have was an expert React Native. We only had 2 months or 2 to 4 months on React Native. I think 2 to 4 months on React Native before we started the actual timing and depth. So yeah, that's an interesting question. So
it seems like a framework that's meant for web developers trying to mobile
yes.
stuff, right? So you pigeonhole those people that
Yeah, so those web people were doing the React Native piece portion of it. We helped them out sometimes when they got stuck. And these still took 3 times long.
Kind of scared to ask this question, but how's unit testing with React Native?
Oh, it's not bad. That's pretty good. Yeah, you can do. There's Jest. Yeah, we mocked out a whole bunch of stuff to get this testable. So yeah, having whether or not it's unit testable, you can unit test it with some work, and like there are some difficult issues you have to like solve. Like sometimes one library will you're mocking something out, another like a networking layer, and another library will have mocked that out in some way you can't quite understand or find, and then there's some strange, difficult to solve problems in that space, but it can definitely be done.
Okay, so I guess I would have to like learn completely a new mocking framework, testing framework, just to test on React Native.
Oh, for sure, because you're only testing the JavaScript portion. Basically, you create. One thing I didn't talk about was the virtual DOM. So there's like a so React Native, actually React creates like a virtual DOM, and then so your tests also can mock that virtual DOM. One thing they do that's weird with testing is they have like a thing that creates a snapshot of what your view hierarchy looks like. And if it changes, your test breaks. And what you end up doing is just always updating the test so it has the new state of the view hierarchy. So it's kind of like a useless test, but on the examples you'll see that test often.
Doesn't the fact that you can just like hit refresh in your application, doesn't have to compile, doesn't have to deploy the device, doesn't that make it all worthwhile?
You know what? That's an interesting problem because Walmart published a post where they said that the React Native development environment is amazing because of instant
Refresh.
Hot reload. Because of hot reload. It's just amazing. And I'm like, are you kidding me? Do you know how many times hot reload doesn't work? You know how much times I had to debug hot reload? But yeah, it is good. But it in no way makes up for the other. Basically, the flakiness of the build is something I didn't get into, but it is an unending source of annoyance. Like, when I deploy, that's why how many people actually have instant run enabled? A couple people use it. Great, man. I hate deploying and not knowing, is that my latest code?
Yeah.
You know, I just wasted, I don't know how many cycles I tested it. It doesn't work, it's not my latest code.
But doesn't it work, like, it's supposed to work amazingly in React, doesn't it?
Yeah, those hype blogs say it works great. Yeah, I've worked with it for months, never found it working great. And sometimes those use cases where you want a hot reload is sometimes that's a small portion of your dev cycle, because when you're doing native, hot reload is great. I think that Flutter is also doing hot reload, but that's why they're trying to make the editor faster, so you can just see your changes in the editor, so you don't necessarily require a rebuild of the app, and trying to get this to work. Yeah, so Walmart has said like this is like the most amazing development environment ever. Has just released like last week a whole development environment to make using React Native easier. It's called Electro. So they basically have a whole platform on React Native to make React Native better, even though they posted a blog saying it's the best development environment ever.
How do you feel about recommending code that hasn't hit 1.0 yet? I'm saying like React Native, it's like 1.4.
That's true, yeah. They're at 4.9 now. They were at 4.1 earlier in the year. I don't mind using a library. I used Node for a long time before it hit 1.0. Some people are just stubborn, or some people are just stubborn. But maybe it'll get better, but I think fundamentally the architecture is going to be at a disadvantage.
How do you find the performance of React Native versus something like Cordova, right? Where you're just doing everything natively web versus kind of the UI experience with the native components that React like exposes?
So I'll be honest, I don't have a lot of experience with Cordova, or any experience with Cordova.
Or like any like WebView based like.
I've done WebView. So a couple of years ago, hybrid apps were very popular. Probably a bunch of people have worked on hybrid apps before. So the idea is you get code sharing. and everything's rendered in WebView. And then those customers came to, not this company, but other companies, they come to us a year later and say, hey, we got more budget, can we do the whole thing and need it again? And we literally just break the whole thing and need it because it just wasn't there. And you would actually end up similar issues like the issue of having a longer development time at the last mile isn't unique to React Native at all. It's those hybrid apps had similar issues. You would suddenly get these device-dependent issues where the text view was black and people couldn't enter it, and it's only on this one device, and it's because stupid Sony has done something weird with their thing, with their keyboard, that like stops that web view from working. But because it's not a common use case, they didn't find it, and then you're stuck. So, I don't know if that answers your question.
How is debugging in React Native?
So you can set it up so that you can actually step through your code. You can step through your JavaScript code. I liked WebStorm. Half the team liked WebStorm, half the team didn't like WebStorm, but I really liked it. And you could actually step through your code in WebStorm, so it's pretty good. Once you got it set up. All right, thanks everyone.